Okay, so let's graph an equation of a line that is in slope-intercept form. And this is slope-intercept form. Y equals mx plus b. M being our slope and b being our y-intercept, or where the graph crosses the y-axis, the y-axis. So that is our y-intercept. If you're not familiar with finding the slope on a coordinate grid, please see my video finding the slope on the coordinate grid. All right. But I want to graph this line here, y equals 4x minus 3, and it is in slope-intercept form. So according to how it is written, the number in front of your x is always your slope. That's my m. The number or the constant that is by itself is always your y-intercept, or where that graph crosses the y-axis. So in this case, my slope is 4, and my y-intercept, or my b, is -3, because I have a -3. And what I want to do, I want to start at my y-intercept and plot that point, and then use my slope to find other points on the graph and draw my line using a ruler. All right. So my y-intercept is -3. Okay, this is x-axis, y-axis. So vertical axis, horizontal axis. All right, so -3 on my y-axis. I start at the point 0, 0, and I go down 1, 2, 3. So I'm plotting -3. Then I'm going to use my slope to get my other points. And so my slope is 4. And so from that point, I'm going to go up 1, 2, 3, 4. But what number is under every whole number? There's a 1 underneath every whole number. So my rise would be 4, but my run would be 1. Okay? So whenever you have a whole number, it's always a 1 underneath. All right, and the top number being your rise, and the bottom number being your run. All right, so starting at the point -3, which is my y-intercept, I count up 1, 2, 3, 4, and then over 1. I'm going to do it again. Up 1, 2, 3, 4, over 1. I'm going to keep going. 1, 2, 3, 4, over 1. Well, what about some ordered pairs the other way? Now, since this is a positive 4 over 1, what if I rewrote this as -4 over -1? That, of course, reduces to positive 4 over 1, but I could use that to get points on the other side of my y-intercept. So I could do -4, so I could count down from that point, 1, 2, 3, 4, and then back to my left 1. So down -4 to the left, but my run would be -1. And I can do it again, 1, 2, 3, 4, and that will actually be off the graph, and that's okay. So now I have enough ordered pairs to draw my line. And I'm going to try to draw this line as straight as possible through. And of course, you would probably get a little neater on your paper, because you're not going to be drawing a gigantic line on a graph like this. And so I've graphed this line, y equals 4x minus 3. That graph should cross your y-axis, whatever that number is. So in this case, it's -3, and I have a slope of 4. All right, so let's try graphing this line here. We have y equals -2/3 x plus 2. So again, m, the number in front of x, is my slope. So in this case, my slope is a -2/3. My y-intercept, where that graph crosses the y-axis, is 2. So starting at 2 on my y-axis, starting at 0, 0, I'm going to go up 1, 2. So that is my first point I'm going to plot. And my slope is -2/3. So in order to get ordered pairs to the left and to the right, I'm going to use the negative first with my 2, with my run. So I could say that this is negative 2 over positive 3. So from this point, I will go down 1, 2, and I will go to the right 1, 2, 3. If I'm using the 2 as the negative. And I could go down 1, 2, over 1, 2, 3. Down 1, 2, over 1, 2, 3. But I want points now on the other side of my y-intercept. So I could actually use the negative with the 3 or with the run. Okay, because remember, if you have a negative fraction, that means the entire fraction is negative. You can apply it to either the numerator or the denominator. All right. So to get points this way, I'm going to use a positive 2 for my rise. So I'm going to go up 1, 2. But then since my 3 is negative, I can go back 3. So I can go up 1, 2 and back 1, 2, 3. Up 1, 2, back 1, 2, 3. Up 1, 2, back 1, 2, 3. All right, and now I see that those points are all on the same line. And drawing your line, again, trying to get it as straight as possible on this large graph. And I have graphed this equation of this line, y equals negative 2/3 x plus 2. All right, so now what if you wanted to graph an equation in slope-intercept form, but it is not already in slope-intercept form? So what do we need to do? We need to rewrite it so that it is in slope-intercept form. All right, so this is actually a literal equation because I have two variables. So if you're not familiar with how to solve or rewrite literal equations, please see my video 1-step literal equations and 2-step literal equations, and I'll link it at the end of this video. All right, but I want to solve this equation for y because slope-intercept form is y equals mx plus b. So I want to isolate the y or get the y by itself on one side. And so what I do, I want to subtract 3x from both sides. Okay, because that is a positive 3x. So I'm subtracting 3x. It leaves me with 2y equals, since my term in slope-intercept form with the x's first, I'm going to write this negative 3x first. That 8 is positive, so I'm going to write it as a plus 8. So now I'm getting closer to slope-intercept form, but I'm not there yet. All right. I have a 2y, and we read this as 2 times y. What is the inverse of multiplication? Division. So I want to divide both sides by 2. Cancels out on my left-hand side. So I can rewrite this as negative 3 over 2. Negative 3 over 2x. Of course, if I could reduce the fraction, I would go ahead and reduce it, but I leave it as a fraction because I cannot reduce negative 3 over 2. All right. And then 8 divided by 2, I can reduce that to 4. 8 divided by 2 is 4. And so now I have this equation written in slope-intercept form. I've isolated my y value. I have a term in front of x. My term in front of x, or my number or fraction in front of x, is my slope. In this case, my slope is negative 3 over 2. My y-intercept is 4. So I'm going to graph it using the same method that I used in the previous 2 examples. So 4 on my y-axis. 1, 2, 3, 4. All right. Slope, negative 3 over 2. I'm actually just going to pick 1 point on each side. So I'm going to go down 3. 1, 2, 3, and over 1, 2. Okay. And then I could also use, like in my previous problem, I could use the negative with the numerator or the denominator. So that's going to be positive 3 over negative 2 because I want to point the other way. So I could go up 3, 1, 2, 3, and then back 1, 2. And honestly, to graph an equation of a line, You only really need 2 points. I like to use 3 just to be a little more precise, but honestly, you really just need 2 points. All right, so I'm going to, can't find my ruler now. I don't know what I did with my ruler, so I'm just going to freehand this line, and it should be a straight line through those 3 points. And one thing you should analyze about your graph, notice you have a negative slope, and so your graph should fall from left to right because we read from left to right. So that graph falls from left to right or goes down. If you have a positive slope, your graph should go up from left to right. All right. And so now, hopefully, you've learned how to graph equations in slope intercept form.